Today we will complete the circle diagram which we started earlier. So just quickly remember that when you consider the stator impedance as well as core losses, if this is your phase voltage, then the circle diagram will look like this is your no load current, and the no load power factor theta. And this can be obtained from the no load phase. Now the circle diagram will look like this parallel branch where R1, X1, X2 dash and R2 dash by X are in series. The circle diagram of that will be of this nature. Okay. And the standstill condition, suppose this is S equal to 1, this point S equal to 1, that is slip equal to 1, and this point we are calling X. Now, and this is the input power. If you drop a perpendicular chase, this will be the input power. Sorry. So SM, say P you call. So SM is the total input power to the system. From this, if you subtract the core loss, you get the remaining power which will supply the stator copper loss, rotor copper loss and output mechanical power. Now, during standstill condition, this line SP, you break it up in the ratio R1 is to R2 dashed. Suppose these values are known, in this ratio you break it up. Then this line, if you join this line, then this power will give you the air gap power of the machine. This length will be the air gap power, and this length will give you the stator copper loss. And this remaining length is your air gap power, and which is equal to the rotor copper loss during standstill condition. Now, if you at any other operating point, suppose this is the any other operating point, we are calling this as P, so this you change to some B here, this point. So this any other operating point, this length will be the total input power, and let us call this point as D, this point of intersection as K, and this point of intersection as T. Then PD will comprise of the stator copper loss, rotor copper loss, and the mechanical power developed by the machine. So out of PD, this length KD will also the length KD will represent the stator copper loss at slip S. This is very easy to prove because of the fact that in a circle, I can write, for example, OS whole squared. This length square is equal to, if you call it this point as O and this point as say G, it will be OB into OG. This can be shown. This length square equal to this into this. Similarly, you can write OP whole squared as equal to OD into OG. So if you take the ratio of these two, OS squared by OP squared, you will be getting OB by OD. And OB by OD, if you call this point as Q, will be nothing but QB by KD. Therefore, the length KD will be equal to QB divided by QD divided by OS squared into OP square. This KD length will be like this. Now, what is QB? QB is the stator copper loss at slip equal to 1, standstill condition. And what is OS? OS is the current value at that slip. So that power divided by OS square will give you basically R1. And this multiplied by OP square, the current square at slip S. Therefore, this is nothing but copper loss, stator copper loss at slip S. Similarly, you can show that Tk, the length Tk, will represent rotor copper loss. So, by dividing this standstill length, that is SB, in the ratio R1 is to R2 dash, you get this one. And as I told you, this length is called the torque line, because the length PD, because the length Pk is the air gap power. So air gap power by synchronous speed gives you the torque. So any interception, any line segment lying between the periphery of this circle and this one, vertical lines, will give you the torque produced at that slip. Which one is the output line? Output line is this one. This one is the output line. Because the length PT is the mechanical power output. Mechanical power output of the machine. So compared to the earlier case, torque line shifts in the anticlockwise direction in this fashion. You can, as usual, find out different operating points. Suppose it is asked that what should be the slip at which machine should be operated such that the power factor is maximum. What you have to do? That is the power factor with respect to the supply voltage. Tell me. So from this point, this is the input current is, you remember, I0 plus this one. So you draw a tangent from the origin to this circle, and at this point, if the machine is operated, it will operate at maximum power factor, because any point on this side will have larger angle, either this side or that side. And of course the other things remain, that is, if you want to operate, find out the slip at which maximum torque occurs, you from the center drop a line like this, perpendicular, and wherever it meets, that will be the corresponding to the maximum torque. Similarly, maximum mechanical power output, from this one you drop a perpendicular here, like this, you get the maximum mechanical power corresponding to that point you will be getting. Okay. Therefore, in the circle diagram, if you draw, you need not go on calculating everything, just by graphical way you can find it out. But as I told you, like the earlier case, simplified the equivalent circuit case, here also one can draw a slip line and further reduce the calculations for fixing up the point, and can read the value of the slip very quickly. That I will just tell you how to do it. So now your circle diagram will look like this one, that is slip line. So once again, this is no load current, I0, and this is, suppose, your circle. and this is suppose the standstill condition, operating point S, and this length is divided in the ratio R1 is to R2 dashed, so that this line will become your torque line. Okay. Now, once again, like the previous, this is the voltage phasor axis. You take any point here. You drop a line parallel to this, parallel to this one. Take any point on this. Say something U. You take any point U here. And through U, you have to draw a line what? Parallel to the torque line. Earlier case, the torque line was the diameter itself, so it was horizontal. Now it will be like this. This line is parallel to torque line. And this point U is arbitrary. And then you extend this line. Suppose it meets here. You call this point as V. Then if UV you calls 1, UV represents slip equal to 1, because here slip equal to 1. Then it can be shown if the operating point is something else. Suppose here, this length, say x, ux, then will represent slip.